welcome back. So in the previous video, we have discussed the representation of electric field lines, right? And in this video, what we will discuss, we will see the properties of electric field lines. So here I have discussed 7 very important properties of electric field lines. So the first property we have already seen in the last video also, that electric field lines starts from the positive charge and ends at the negative charge. So if you're having a positive charge here and a negative charge here, so it will start from the positive charge and it will terminate at the negative charge. Clear? The second point is that if you're drawing any tangent, suppose I'm considering this point, okay? If you're considering any point, okay, just a second. If you're considering any point, okay, in this electric field line, if you are drawing any tangent at any point of the field line, it will give you what? The direction. It will give you the direction of electric field lines. So it is written here, tangent to any point on field lines shows the direction of the electric field lines. Clear? The third is what? If you're having electric field lines, okay, they will never intersect each other. Intersection of electric field lines is not possible. Why? Because in the second point, what we have seen, that if two field lines will intersect, then you will have two tangents, because in the second point we have seen direction is given by the tangent, right? So if I consider this point, okay, if electric field lines are intersecting, so at this point you will draw two tangents, right? One tangent will be this way, one tangent will be this way. So you will get two directions, right? This will give you two directions at a single point, and practically that is not possible. So the third property is that two field lines can never intersect each other, because if they intersect, then two tangents drawn at that point will represent two directions of the field at that point, and that is not possible. Clear? Now we will see the field line, the fourth property of the field lines, okay? So for this, what you will see, the relative closeness of the field lines gives the strength of the electric field, okay? Suppose if you're having a positive charge here and a negative charge here, we have already seen the representation, the field lines will be somehow represented this way, okay? It looks this way. So if you see here, as you go away, the field lines will have be what? The closeness will start decreasing, right? This is how it will be there. The closeness will start decreasing. So here, if you see this in this area, okay, in this region, the field lines are close. So this is strong electric field region. And in this, you can see the space is what? The field lines are what? Away from each other. So you will consider this to be weak electric field region. That means the relative closeness will give you the strength of the electric field lines. Field lines close will indicate you strong field, okay, and the field lines away will indicate weak field. Clear? Now you see fifth point. They do not form closed loops. Electric field lines, they do not form closed loops, because if you see, it is starting from positive and ending at negative. It is not starting from negative to positive. If you see here, they are not forming closed loops. For forming closed loops, it should be what? The reaction should be somewhat like this. So they are not forming closed loops. Clear? Now, the sixth point is that they do not pass through a conductor. We know that inside the conductor, there is no charge, okay? Charge lies only on the surface of the conductor, okay? So there will be no electric field lines inside a conductor. Suppose if you're having a conductor, you need to remember one more thing, that the electric field lines are always perpendicular on the surface, okay? If you're having positive charge, the field lines will be moving perpendicular. And if you're having negative, it will move inward. Okay, if you're having positive charge, suppose this is positive charge, so field lines will be perpendicular to the surface. If you're having negative charge, it will be perpendicular but inward direction. This is one more thing about the electric field lines for a conductor. And the last is that for uniform electric field, the field lines are parallel. That means if you're having parallel field lines, okay, uniform fields will be what? They will be parallel, and the distance between them is also what? Equal. They are parallel, that means they are having the same direction. They are equidistant, that means they are having the same magnitude. Clear? And for non-uniform, they will be not parallel. You can draw somewhere, somewhat this type, okay? So this is a non-uniform electric field. They are not equidistant and not parallel. And for uniform, it is parallel because they are having the same direction, and they are equidistant because they are having the same magnitude. So these are very easy 7 properties of electric field lines. So whenever you're asked in the exam that you just need to mention a few properties of electric field lines, you can write a few of them. Okay, that's all in this video. Thank you so much. Have a good day.